Welcome to the Explainer. From the moment we're born, we're basically learning sponges. But how much of that learning comes not from a classroom, but just from watching? Today, we're digging into the powerful and often invisible ways we learn simply by observing the people and the world all around us.
And believe it or not, it all starts with a kind of weird question. What on earth does a teddy bear have to do with how you learn? It sounds strange, I know, but the answer to this question actually gets to the heart of a huge revolutionary shift in how we understand our own minds. So let's start with what I'm calling the tale of two teddies. This story, which comes from some really foundational research by Dr. Sudheendra S, is the perfect way to see the power of observation in action.
Okay, so check this out. Dr. Sudheendra's research set up two incredibly simple scenarios. In the first one, an adult gets really aggressive with a teddy bear, basically using it as a punching bag right in front of a 3-year-old. And what happens? Later, that same kid was destructive with their own toys. Now, in the second scenario, an adult treats the exact same kind of bear with love and affection. The result? You guessed it. That child was gentle and protective of their toys. Same bear, same age group, totally different outcomes, based only on what the child saw.
Now, you might be sitting there thinking, well, duh, of course that's what would happen. But here's the kicker. If that seems obvious to you today, we really have Dr. Sudheendra to thank for it. Because at the time, this was a groundbreaking idea that flew in the face of what almost everyone in psychology believed about how we learn.
Yeah, this research really forced a huge shift in thinking. It showed that there was way more to learning than just simple rewards and punishments. And to get just how big of a deal this was, we got to take a quick look at the old school way of thinking.
For decades, a theory called behaviorism was king. It basically had two main parts. You had classical conditioning. You've probably heard of Pavlov's dogs slobbering at the sound of a bell. That's about linking a stimulus to a response you can't control. Then you had operant conditioning, like giving a dog a cookie for doing a trick, which is all about linking a choice you make with a consequence. For a long time, that was pretty much seen as the whole story of learning.
But that teddy bear experiment, it helped bring in this brand new idea, social cognitive learning. Now, this theory doesn't just throw out behaviorism, but it adds this absolutely critical new layer. It says we also learn in a social context, by watching people, imitating them, and modeling what they do. In other words, there's thinking involved. Our brains are actually part of the equation.
And this cognitive piece, this thinking part, is so important. It showed us that learning isn't some simple one-size-fits-all process. Our own biology and our own thoughts can completely change the game.
This shows us a huge limit to that old school conditioning. Our biology gets in the way. For instance, if you get food poisoning from, say, some bad upma, you develop a lasting dislike for the taste of upma, right? Not the sight of the plate or the restaurant you were in. That's because our bodies are biologically hardwired to connect nausea with what we ingest. And it's the same deal with animals. It's way easier to teach a pigeon to peck a button for food, because pecking is natural for them, than it is to teach it to flap its wings for that same reward. Our biology creates these preferred learning pathways.
And it's not just our biology. Our conscious minds can step in and just override the whole thing. Imagine someone is in treatment for alcohol addiction and they're given a drug that makes them feel sick whenever they drink. Now, pure conditioning would say, great, they'll associate alcohol with sickness. But what if they know it's the drug making them sick, not the alcohol? Their own thinking, their cognition, can completely break that intended connection.
This leads us to an even wilder idea. Sometimes we learn things without any reward at all, and without even realizing we're doing it. It's called latent learning. Think about it like this. You're wandering around a new part of town, not trying to memorize anything, just looking around. You're subconsciously building what's called a cognitive map in your head. Then later, if a friend asks you how to get to that one coffee shop, you might shock yourself by actually knowing the way. You learned it latently, without even trying, and with zero reward.
Now, this was proven in a classic experiment with rats in a maze, and the results are just wow. So one group of rats always got a food reward at the end. And yeah, they got faster over time. Another group was never rewarded, and they didn't really improve. But the third group, this is the amazing part. For 10 straight days, they got no reward, and they were terrible at the maze. But then, on day 11, they found a reward at the end. And just like that, their performance shot through the roof, even surpassing the rats that were rewarded from day 1. They had been learning the maze the whole time. They just didn't have a reason to show it yet.
So, if we're learning all this stuff just by watching and walking around, how is our brain actually doing it? Well, the answer is pretty mind-blowing. It turns out we have a built-in mirroring system.
The simple truth is we are natural-born imitators. This kind of learning, called modeling, is basically how human culture spreads. Think about it. Slang, fashion trends, how to use your phone, how to use a fork. We learn it by watching. Chimps even learn how to fish for ants with sticks this way. It's fundamental.
And the discovery of how this works? It was a complete accident. Back in the 90s, some Italian researchers were monitoring a monkey's brain, watching for neurons that fired when it did stuff like eating a peanut. But one day, a researcher just walks into the lab licking an ice cream cone. The monkey is just sitting there watching him, but suddenly, the monitor attached to its brain starts going wild, as if the monkey itself were licking the ice cream. This led to the incredible discovery of mirror neurons. These are brain cells that fire both when we do an action and when we simply see someone else do that same action. It's like our brain is running a full-on simulation of what the other person is doing, in real time. This is the likely neurological basis for imitation, for observational learning, maybe even for empathy itself. Okay, so let's tie all of this together. If we're built to learn by watching, and if our brains literally have a system to mirror the actions of others, what does that mean for us in our day-to-day lives? It means something really important. Whether you like it or not, you are a role model. Dr. Sudheendra, the scientist from our teddy bear story at the beginning, he puts it this way. It's just a powerful, simple reminder of the responsibility we all have, especially when we're around kids.
And you see this play out in a million real-world ways. Research shows that kids learn how to respect their parents by watching how their parents treat the grandparents. If they see complaining and negativity, that gets mirrored. If they see love and support, that gets mirrored too. It all comes right back to that tale of two teddies. The behavior we model is the behavior they learn.
And look, this isn't just about childhood. Way back in the day, the statesman Lord Chesterfield said this. He believed that imitation literally shapes the core of who we become. It suggests that our friends, our coworkers, the media we consume, it's all constantly molding us through this quiet, powerful process of observation. So we'll end on this thought. The science is clear. Our brains are designed to mirror the world around us. We are literally built to learn by watching. So the real question, the one for you to take with you, is this. Knowing your brain has a mirror, what are you choosing to reflect? Thanks for joining us on The Explainer.